This lecture will be discussing some examples for solving the determinant of a matrix by Laplace method. Let's have example number 1. So solving for the determinant of matrix A using the Laplace method is we first identify or choose any column or row as our reference. And in this case, we'll have the second row. So for this, in the Laplace method, we're going to get the sum of the products of the element in our chosen reference multiplied to its cofactor. So in this case, we'll have element 2, 1 times its cofactor, element 2, 2 times its cofactor, and element 2, 3 times its cofactor. For the first element, that will now be negative 2 times negative 4, 2, negative 1, 6. So where did this come from? So this came from the cofactor of element 2, negative 2 is 2, 1. So for the cofactor, we remove this row. So what will remain will be 4, negative 1, 2, and 6. So computing now for their product, we'll have negative 2 multiplied 2, negative 4 times 6, that's 24, minus 2 times negative 1. So the negative sign here comes from negative 1 raised to 2 plus 1. For our shortcut from our cofactor lecture, it will be positive, negative, positive, negative. Okay? Simplifying now this equation, we'll get A21 times its cofactor is equivalent to 52. So let's move to the next element. We have A22, which is now equal to 1, and its cofactor will be determined by eliminating the column of A22. So we'll have now 1 times positive, since this is negative 1 raised to 2 plus 2. It's a positive value. Times its minor matrix 3, negative 1, 5, and 6. So computing now, we'll have 1 times 3 times 6 is 18, minus 5 times negative 1 is negative 5. For the product now of A22 and its cofactor is 23. Then we have A23. So the element is 3. Cofactor will be taken by eliminating our second row and third row. So we'll have now 3 times negative 3, 4, 5, 2. So computing will get 3 times negative 3 times 2 minus 5 times 4, which will give us a value of 42. So adding up our values of the products, so we'll have the determinant of A will be 52 plus 23 plus 42, which is equal to 117. And if we are going to compare this value, this is the same value that we have arrived or that we have computed in example number 1 of the pivotal element method video. So for the Laplace method, we could resolve example 1, matrix E, by using a different reference column or reference row. So let's try solving matrix E, but instead we are going to use now the second column. So in this case, we are going now to solve for the product of element E21, that's A12, A22, and A32. Okay, so for A12, that will be 4, eliminating its row, will now have 4 times negative cofactor or matrix minor is negative 2, 5, 3, 6. That's now equal to 4 times negative, negative 2 times 6, minus 5 times 3, giving us a value of 100. So next, we move on to element 2, eliminate the second row. So we'll have now E22, 1, and its cofactor will have a positive sign. And its minor matrix is 3, 5, negative 1, and 6. So computing will have 1 times positive, 3 times 6 minus 5 times negative 1, which is equal to 23. And lastly, we move on to the third element, A32, eliminate its equivalent row. So we'll now have A23 is 2, cofactor is a negative value, minor matrix is 3, negative 2, negative 1, and 3. So computing now, that will be 2 times 9, negative 2 times negative 1, which is now equal to negative 14. So adding them up, determinant of matrix A is 108 plus 23 minus 14 will also give us a value of 117. So this proves now that any column or any row that we use for Laplace method will give us the same value. So we have example number 2, given matrix F, which is a 4 by 4 matrix, determine the determinant by Laplace method. So again, we can choose any column or row for the matrix as our reference row or column. So in this case, I'll be choosing the fourth column for our computation. So in this case, we'll now be solving for the product of the element and its cofactor. So we'll have 1, 4, 2, 4, 3, 4, and 4, 4. So let's start with the first element of our chosen column. So we have F14 times C14. So F14 is 1. 1 plus 4 will give us a negative value. Since it's odd, its minor matrix will be this one. So we have 3, 1, 1, 2, 0, 2, 1, 1. Okay. So with that, we can now solve for our product. So we'll have 1 times negative 0, 2, 2. So upward diagonal, so we have 0, 6, 2. That will now be equal to 1 times negative 4 minus 8, or that's equal to 4. So next, we have second element. So that's F1 or F24 times the cofactor. And that will give us now 3. 2 plus 4 is an even number, so it is a positive value. And its minor matrix is 2, 3, 3, 1, 0, 1, 1, 2, 1. Computing now this matrix will arrive at 3 times 0, 3, 6 minus 0, 2, 3. And it will be simplified to 3 times 9 minus 7, or that's equal to 6. So next, we have our third element of our chosen column. So we have F34 times C4. We'll have now 2 times 3 plus 4 is an odd number, so that will be a negative minor matrix, which is 2, 3, 3, 3, 2, 1, 1, 2, 1. Simplifying, we'll get 2 times negative 4 plus 3 plus 18 minus 6, 4, 9. That is equal now to 2 times negative 25 minus 19, which is equal to negative 12. Then, lastly, we have the last element, 0. So we have F44 times C44. So that will be 0. 4 plus 4 is a positive, is an even number, so it's a positive minor matrix. So we have 2, 3, 3, 3, 2, 1, 1, 0, 1. Simplifying, it's 0 times the sum of the upward diagonals minus the sum of the down, or of the downward diagonals minus the sum of the upward diagonals. That's equal to 0 times 7 minus 50, which is equal to 0. So adding up now our computed values for 6, negative 12, and 0 will give us a value of negative 2. So the determinant now of matrix F is equal to negative 2, which is the same value that we have computed for example number 2 using the pivotal element method. So we have example number 3. So we're given matrix C, which is a 4 by 4 element. So we choose any column or any row that is convenient for our solution. In this case, I'll be using the third row. In this case, we'll now be solving for the product of C 1 3 1 times the cofactor of 3 1, the element 3 2 times its cofactor, element 3 3 and its cofactor, and element 3 4 times its cofactor. Okay? So we start off with C31 times its cofactor, and we do that by eliminating the first column first. So we'll have this element, and then the minor matrix 3 plus 1 is even, therefore we have a positive minor matrix. So with that, we'll have 1 times positive minor matrix. So we get 1 times 56 minus 36 minus 50 minus the quantity 4 minus 126 minus 60. Simplifying, we get 1 times 5 minus negative 182, which is now equal to 187. So next, we move to the second element, 3, 2. So we have element 3, 2. Then eliminate its column. And we're going to use its minor matrix. 3 plus 2 is add. So therefore, we have a negative minor matrix, where the cofactor is a negative value. So with that, we'll have now negative 2 times negative times the matrix 2, 1, 3, 3, 1, negative 1, negative 3, 1, and negative 4. So simplifying, we get negative 2 times negative quantity 8 plus 27 minus 3 minus the quantity negative 3 minus 18 minus 12, or that's negative 2 times the negative 32 minus negative 32. And that will give us a value of 130. So next we have our next element, 2. We have 3 plus 3. It's an even sum. So therefore, our cofactor is a positive matrix. So removing now our column, we'll now arrive at a matrix which is using this elements. So we have 2 plus the matrix 2, 1, 3, 14, 5, negative 4, 1, 3, negative 4. So simplifying, we get 2 times positive quantity negative 40 plus 126 minus 4 minus the quantity 15 minus 24 minus 16. Or that will give us now a value of 294. And lastly, we solve for 3, 4. So this element, so we have negative 3. We remove the column. 3 plus 4 is an odd number. So therefore, we have a negative cofactor. Then we are going to use the following elements for our minor matrix. So we have 2, 14, 3, 1, 5, negative 1, 3 minus 4 minus 3. So simplifying, we'll now get the value of the element 3, 4 times its cofactor, which is equal to 285. So from here, we add up now our computed values, 187, 130, 294, and negative 285, which will give us a value of 326. So therefore, the determinant of matrix C is equal to 326, which is again the same as the value we have computed using the pivotal element method. So we have our last example, example number 4. So given matrix E, which is a 4 by 4 matrix. So again, we are to solve now for the product of the elements and the cofactor of the row or column that we are going to use. So in this case, I'll be choosing the first row. So by choosing the first row, we'll be solving for the product of the element and cofactor of element 1, 1, 1, 2, 1, 3, and 1, 4. Okay. So with that, we start first with element 1, 1. So for its cofactor, remove this column and we use this matrix for its cofactor. 1, 1 is positive since it's an even sum. So we'll now have negative 2 times positive matrix 4, 0, 2, 1 minus negative 8, negative 1, negative 5, 7, negative 9. So simplifying our equation, we now get the product of element 1, 1 and its cofactor, which is now equal to negative 500. So next, we move on to the second element. We have 1, 2. So we have the element 2 and its cofactor, which is a negative value multiplied to its minor matrix using the elements 5, 8, negative 4, 0, negative 8, 7, and 2, negative 1, negative 9. Simplifying our equation, we'll now get the product of element 1, 2 and its cofactor, which is equal to negative 1, 8, 8, 6. So next, we move on to the third element, E13 times its cofactor. We'll have negative 3 times a positive cofactor, which will be taken from this matrix. Okay. So we'll have negative 3 times positive 5, 4, 2, 5, 4, 2, 8, 1, negative 1, negative 4, negative 5, negative 9. So solving for our matrix, we'll get now the product of element 1, 3 times its cofactor, which is equal to negative 486. And then lastly, we move on to our last element. So we have E14, which is negative 4. Our cofactor is an odd number. So it's the negative cofactor, which will be taken by eliminating the column of the fourth element of our first row. So we'll have this matrix. We have 5, 4, 0, 8, 1, negative 1, negative 4, negative 5, and 7. So computing will get now the product of element 1, 4 and its cofactor, which is equal to negative 1,404. So adding up our computed products, negative 500, negative 886, negative 486, negative 1044. We can now solve that the determinant of matrix E is equal to negative 200 or 2916, which is the same as our computed determinant in our discussion for the example 4 by pivotal element method.